Hello everyone, welcome back to our channel. In today's video, we will be discussing about inverse function. So, let's get started. We'll be discussing today about the inverse functions. Okay, what is then inverse function? Okay, let's start. Let's start with a review. Okay, so a blank is any set of ordered pairs. So what do you think is the answer? A blank is any set of ordered pairs. The answer would be, okay, you are right. The answer would be relations. Okay, relation. We discussed this one in our previous lesson. Okay. Next, a blank is a set of ordered pairs where x is not repeated. Meaning to say, x represents the domain. Meaning, no values in the domain, and the set of domain is repeated. What do you call that one? Again, that's a blank is a set of ordered pairs where x is not repeated. You're right. The answer is function. So you have function. Okay. Next. Okay, just bear with my handwriting, class. Okay. Next. A blank function does not have any y values repeated. A blank function does not have any y values repeated. What do you think is the answer? We mentioned this one also in our first quarter. Okay, the answer would be 1 to 1. Okay, 1. Okay, 1 to 1. So 1 to 1 functions, these are functions in which no y values or no values in the range that has been or that are repeated. So this one, only blank functions can have blank functions. This is in relation to our new lesson in today's video. So only, the answer would be only 1 to 1. Okay, only 1 to 1. Only 1 to 1 functions can have blank functions. So what do you think is the answer here? Okay, can have, okay, you are right. The answer would be inverse. Okay. Okay, so we have here, so again, for our review, fill in the blank. A blank is any set of ordered pairs. The answer is relation. Next, a blank is a set of ordered pairs where x is not repeated. The answer is function. A blank function does not have any y values repeated. The answer is 1 to 1. Only blank functions can have blank functions. The answer is only 1 to 1 functions can have inverse functions. Okay? So you will be guided with these concepts as we continue with our discussion. Okay, so what is then a function? Okay, as a review, again, a function is a mathematical process that uniquely relates the value of one variable to the value of one or more variables. So we have there the input and the output. Okay, so we have, for example, this is input x, and we have here the function f of x. So the output variable y. Okay, that is how the function is being expressed or presented. So you have function y or that is the same as f of x. Now remember that we talk about functions, talking a set X and mapping into a set Y. So we have here the mapping. So this is our set X or domain, and this is our set Y or our range. So an inverse function would reverse that process and map from set Y back into set X. So as you've noticed, the arrow now, the arrowheads is from the range to the domain. That is from right to left. Okay. So as you've noticed, 2 has been mapped to 2, 6 has been mapped to 1, 4 has been mapped to 3, 8 is mapped to 4, and 10 is mapped to 5. Okay, let's proceed. So if we map what we get out of the function back, we won't always have a function going back. So not all the time that when we are going to map, okay, a function on the other way around, meaning from range to the domain, is not all the time that we will get a function. So we have here, if we map what we get out of the function back, we won't always have a function going back. So just like this one, our domain is 1, 2, 3, 4, and 5, and our range with values 2, 4, 6, 8. Okay? Since going back, 6 goes back to both 3 and 4. Remember, if this is our function, this is an example of function because none of our domain repeats. It's not repeating. However, if we are going to go back, let's say from the range, we're going to map from the range towards the domain, as you've noticed that 6, okay, this one, 6 goes back to both 3 and 5. 6 has a pair of 3 and 5. The mapping going back is not a function. These functions are called many to one functions. Okay, if it is like this, meaning to say this is originally a function. However, since as we've noticed, based on our observation, none of our x values or none of the values in the domain is repeating. So it is definitely a function. However, our values in y repeats. 6 is repeating. You have 3 is paired with 6. 5 is also paired with 6. Okay? So if we're going to get the inverse, if we're going to do the other way around, 6 here will repeat. So meaning the inverse of this function will no longer be a function. So basically, this original function is called many to one functions, and for many to one functions, we cannot get the inverse. Okay, let's continue. Only functions that pair the y value in the range with only one x will be functions going back the other way. These functions are called one-to-one functions. Meaning to say, one value of our x is paired with another value of y. None of our x is repeating and none of our y or range is repeating. So the ordered pairs of the function f are reversed to produce the ordered pairs of the inverse relation. Example, given the function f, you have here the set of ordered pairs 1, 1, 2, 3, 3, 1, 4, 2. Its domain is, you have 1, 2, 3, and 4. So you have it here. And its range is, you have 1, you also have 3, you also have 1 and 2. As you've noticed, 1 is repeating. 1 has been repeated, so we're going to write that once only if we're going to make a set notation, express the range into a set notation. Okay. So the inverse of this one of f is 1. Okay, the inverse of this function would be 1, 1, 3, 2. This one, 3, 2, 1, 3, 2, 4. Okay? Meaning to say, we just simply switch the value of our x and y. This our x coordinate, is y coordinate. So we have 1, 1. Here, instead of 2, 3, we have 3, 2. And from 3, 1, we have 1, 3. And 4, 2, we have 2, 4. The domain of the inverse relation is the range of the original function. And the range of the inverse relation is the domain of the original function. However, this will no longer be a function because if we're going to interchange the values of our domain and range, our domain will have a value that will be repeating, particularly number 1. Okay, let's continue. So how do we know if an inverse function exists? Okay, inverse functions only exist if the original function is 1 to 1. Otherwise, it is inverse. It is just simply an inverse relation and cannot be written as inverse of x or the inverse of f of x. So what does it mean to be 1 to 1? So there are no repeated y values. Okay? For us to know that a function is 1 to 1, meaning there must be no repeated y values. And we already know that a function, for a function or for a relation to be a function, there must be no repetition of our domain values. Let's continue. We have the so-called horizontal line test. I know you are familiar with the vertical line test. That is for us to identify if a relation is a function or a graph is a function or not using the vertical line test. Meaning to say, if we're going to draw vertical lines, for a graph to be a function, it must intersect only at most one point. Otherwise, it will not be considered as a function. Now, for the horizontal line test, used to test if a function is 1 to 1. If the line intersection more than once, then it is not 1 to 1. Therefore, there is not inverse function. Now, consider this example. The function y is equal to x squared minus 4x plus 7. Always remember that y is the same as f of x. Is not 1 to 1 because a horizontal line can be or can intersect the graph twice. Okay, as you've noticed, this is a parabola. So this is a function. The graph is a function because if we're going to draw vertical lines here, it will only intersect at one point, right? So this is definitely a function. However, the question is, we are now talking about horizontal line test. For us to know, okay? For us to know if this is a one-to-one function, we need to use the horizontal line test. And for the horizontal line test, if, okay, the line intersection is more than 1, then it is not 1 to 1. So here is an example of the horizontal line, and the horizontal line intersect 2 points on this graph. Therefore, it is not a 1-to-1 function. Okay, so this point 0, 7 and 4, 7, as you've noticed, the y value is 7. It has been repeated. Let's proceed. Apply the horizontal line test to the graphs below to determine if the function are 1-to-1. Okay, letter A. Y is equal to x cubed. Now, this is the graph of the function y is equal to x cubed. Again, y is equal to x cubed is the same as f of x is equal to x cubed. So, the horizontal line is this one, the red one. So, even if we're going to draw as many as horizontal lines as we can, it will only intersect at one point. Therefore, this is a one-to-one function. So, if it is a one-to-one function, then the inverse is also a function. Now, how about letter B? Y is equal to x cubed plus 3x squared minus x minus 1. Okay? This is now the graph. Now, if this is the graph, remember, this is a function. But if we're going to use horizontal line test to this graph, we've noticed that it intersects 3 points. If it intersects 3 points, it's not a one-to-one function, meaning the inverse of this function is only a relation but not a function. Okay, let's continue. The graphs of a relation and its inverse are reflections in the line y is equal to x. So, find the graph of the inverse relation geometrically from the graph of f of x is equal to 1/4 times the quantity of x cubed minus 2. So, the ordered pairs of f are given by the equation y is equal to 1/4 times the quantity of x cubed minus 2. So, the ordered pairs of the inverse are given by x is equal to 1/4 times the quantity of y cubed minus 2. As you've noticed, the variables are just being interchanged of x and y. So, considering that the red one, this function has an equation of x is equal to the quantity of y cubed minus 2 all over 4. And the blue one, this one, has an equation y is equal to the quantity of x cubed minus 2 over 4. And this green line here is a graph of y is equal to x. Okay. So, we've noticed that the red is just simply a reflection of the blue one. So, this is how the two functions that are inverse to each other looks like when they are going to be graphed. Okay, let's continue. So, functions and their inverses are symmetric over the line y is equal to x. So, over the line y is equal to x, they are symmetric. So, if this is y is equal to f of x, this is the inverse of f of x. If this is AB, the ordered pair AB, here the corresponding ordered pair will be BA. Okay, let's continue. Now, this would not be a one-to-one function because to be a one-to-one, each y would only be used only once with an x. Okay, that's the first. Okay, just disregard this one. Let's focus on the next mapping. This mapping is a one-to-one. Why? This is a function. And this is considered as one-to-one because each value of our x is paired with only one y, and each one or each y is paired with only one x. So only one-to-one functions will have inverse functions, meaning the mapping back to the original values is also a function. Okay, let's proceed. So recall that to determine with a graph if an equation is a function, we have the vertical line test. If a vertical line intersects the graphs of an equation more than one time, the equation graph is not a function. So this one, this is the graph, the red one, and we use the vertical line test. It only intersects, the blue one are the vertical lines. It intersects at one point only, meaning this is a function. Okay, and this one is not a function. Obviously, this one is a function. Okay, now to be one-to-one function, each y values could only be paired with one x. Let's look at a couple of graphs. Again, so we're going to go back. So in this graph, look at y value. For example, y is equal to 3. And see if there's only one x value at the graph for it. So as you've noticed, for the value, the y repeats. The value of y repeats. So this is not one-to-one. Here, For any y value, a horizontal line with only intersection, the graph 1, so will only have one x value. Therefore, this is a one-to-one function. Okay. Now, let us proceed to the historical background. So, you may be asking, like, you might be asking, where does the function originates, or the word function originates? So, let's have just a brief background about function. Okay. So, we have here the first one. We have Galileo gave the statements of dependency of one on another. So, are you familiar with Galileo, class? We have here Galileo di Vincenzo. Galileo actually was an Italian astronomer, a physicist and engineer, and sometimes described as a polymath. Commonly referred to as Galileo, his name was pronounced. He was born in the city of Pisa, then part of the Duchy of Florence. Okay? So, he was the one who gave the statements of dependency of one on another. So, that's why we have the x and the y values. And the second one, we have Leibniz. Okay, so who is Leibniz? So, in 1673, Leibniz used the word function. Okay, the full name of Leibniz, we have Gottfried Wilhelm Leibniz, who was a German polymath, active as a mathematician, philosopher, scientist, and diplomat. So he is one of the most prominent figures in both the history of philosophy and the history of mathematics. So he wrote works on philosophy, theology, ethics, politics, law, history, and philology. Okay, again, he's the one who used the word function in 1673. Now, what about the third one? Are you familiar with Euler? So, who is Euler, by the way? Okay, so Leonhard Euler was a Swiss mathematician, physicist, astronomer, geographer, logician, and engineer who founded the studies of graph theory and topology and made pioneering and influential discoveries in many other branches of mathematics, such as analytical number theory, complex analysis, and infinitesimal calculus. Okay, so it's the one who started or introducing the notation f of x in the year 1734. Okay, so that is just simply a brief historical background in function. Now, let us proceed. Let us continue. So, what is again inverse function? So, let f be a function with domain D and range E. So, the inverse of f is the function f of negative 1, defined by the inverse of b. The inverse of a. You have f of b is equal to a, where it's chosen so that f of a is equal to b. So the inverse of f of x is equal to x. Then f of inverse of x is equal to x. Okay. So what functions are invertible? Again, in order for a function, inverse function to be a function, there must be only one a in D, corresponding to each b in E, meaning to say one-to-one functions. Okay, so we have here, such functions are called one-to-one. Okay, so functions are called one-to-one, meaning to say the set of your domain, the values in your domain is not repeating for us to know that that's a function, and no values in our range has been repeated. So that's one-to-one. And the graph of such function passes horizontal line test. We discussed that already. If f is continuous, or if the function is continuous, then the inverse function is continuous too. What do you mean by continuous? So in mathematics, a continuous function is a function such that A continuous variation, we recall, that is a change without jump of the argument induces a continuous variation of the value of a function. This means that there are no abrupt changes in value known as discontinuities. Okay. So we have here the example of one-to-one functions again for us to really be clarified. So every element of the range corresponds to exactly one element of the domain. This is one-to-one. This domain and range, that is a one-to-one function. So why is it that not all functions that have inverse? Okay, all functions are not one-to-one functions because there are many to one functions, meaning to say, or many to one correspondence that is also considered a function. Okay, but only one-to-one function, which is an inverse function. Now, why all functions that have inverse? Take a look at this one again. Consider this one. Remember, this is a function, right? However, if we're going to get the inverse, meaning we're going to do the other way around, meaning this will be our new domain and this will be the range. 3 will be paired to both C and D, meaning 3 will be repeating. So it's the inverse is just a relation, it's not a function. Okay, there are steps for finding the inverse. The first is replace y with f of -1 or inverse. Solve for y, then switch x and y, then stick y for f of x. By the way, this second and the third step can be interchanged. We can switch x and y first, then solve for y, then stick y for f of x. Okay. So let's have an example. Okay, given f of x is equal to 5x plus 3 all over 4. Find the inverse of function, find the inverse of f of x. Okay, so in this case, you have your f of x, copy first the given. F of x is equal to 5x plus 3 over 4. The next would be, we're going to replace f of x with y. So we're going to replace f of x with y. So we have y is equal to 5 of x plus 3 over 4. Next would be, okay, next would be this one. So you have your y is equal to 5x plus 3 over 4. Then, we're going, after that, after replacing f of x with y, we're going to switch y and x variable. So here, the x here, okay, for a moment. Okay. Meaning, the x, instead of y here, it becomes x, and instead of x here, it becomes y. Then the next step will be solve for y, meaning our target is y must be written on the left side of the equation. So we have here x is equal to 5y plus 3 all over 4. To eliminate the denominator 4, we're going to cross multiply. Okay? So that is just the same as, remember, that is just the same as there's a denominator which is 1. So that is 4 times x, you have here 4x. Then copy 1 times 5y plus 3, that is 5y plus 3. The next is, we're going to transpose 3 to the other side of the equation. Okay, so this becomes negative 3. So you have 4x minus 3 is equal to 5y. The next thing we're going to do is, divide both sides. To eliminate 5, divide both sides of the equation by 5. Okay, so 5y divided by 5 is y. Okay. 5y divided by 5 is, okay, this will be cancelled out. You have y. Then 4x minus 3 divided by 5. Okay, so we have here y is equal to 4x minus 3 all over 5. So this is now the inverse equation, and we're going to replace y with with the inverse function of with the inverse of f of x is equal to, copy 4x minus 3 over 5. Okay, that's it. That's the answer. Okay. So, functions again, we have here. So, imagine functions are like the die you use to color eggs. The white egg, that is x, is put into the function blue die b of x. Okay, this one. This is a ball, for example, and there's a die. Mix with our water here. So, okay, mix in the water, and then this is the egg. So, the white egg is put in the function blue die, and the result is the blue egg y, the f of x. So, the inverse function undoes what the function does. So, the inverse function of the blue die is bleach, meaning we're going to go back to the original one. So, the bleach will undye the blue egg and make it white. Okay? So, that is the concept. We're just using the analogy on how you are going to understand well the concept of inverse function. So, you have here the inverse function of the blue dye is bleach. So, the bleach will undye the blue egg and make it white. So, it will go back to the original. So, in the same way, the inverse of a given function will undo what the original function did. For example, let's take a look at the square function. F of x is equal to x squared. Okay. F of x is equal to x squared. So, meaning to say, this is the function f of x. So, if x is 3, the answer is 9. This will be the value of our y now. Our inverse function will be the square root of x. The answer 9, if we're going to get the square root of x, the result answer will be 3. It will go back to the original value of our x. Okay, that is our x. Okay, so graphically, the x and y values of a point are switched. So the point 4, 7 has an inverse point of 7, 4. And the point ordered pairs negative 5, 3 has an inverse point of 3, negative 5. So graphically, the x and y values of a point are switched, and if the functions y is equal to g of x contains the points x, we have 0, 1, 2, 3, 4, and our y or our range is 1, 2, 4, 8, 6. Then its inverse is y is equal to the inverse of g of x contains the points. You have your new x and y. You just simply switch the values of x and y. So we have here, the new domain will be 1, 2, 4, 8, 16. You have it here. And our y would be the domain 0, 1, 2, 3, 4. So, if we're going to plot the points for this red table of values, we have it here. Okay? And for the blue one, the blue table of values, we have it here. And remember, this is our graph. F of, this is x is equal to y. This is our reference graph to show the symmetry of the two functions, the inverse of each other. So, as we can see, there is just simply a reflection. Okay? So, the graph of a function and its inverse are mirror images about the line. So, these are reflection, or we call it mirror images about the line y is equal to x. Mean to say, if this is a graphing paper, if we're going to flip this one or fold this one, this graph, the red one and the blue one will coincide. Will just coincide each other. Okay, let's continue. So, find the inverse of a function. Example, y is equal to 6x minus 12. Okay, by the way, y again is the same as f of x. So, if we have here y is equal to 6x minus 12, switch x and y becomes x, and x here becomes y. So, we have your x is equal to 6y minus 12. Then, the next step will be solve for y. So, x is equal to 6y minus 12. Then, we are going to transpose 12 to the other side. It becomes positive. So, we have here x plus 12 is equal to 6y. To eliminate 6 here, divide both sides by 6. Okay? So, retain the remaining term here is y. So, you have here x plus 12 divided by 6. So, we have here y is equal to 1 over 6x plus 2. Okay. So, this is now the inverse. By the way, this is now the inverse function of, or the inverse equation of this one. Okay, let's proceed. Example 2. Given the function y is equal to 3x squared plus 2, find the inverse. So, switch x and y again. So, you have this becomes x, this becomes y. So, x is equal to 3y squared plus 2, then solve for y. X is equal to 3y squared plus 2, transpose 2 to the other side, it becomes x minus 2 is equal to 3y squared. Divide both sides by 3 to eliminate 3 here. So, you have x minus 2 over 3 is equal to y squared. Remember, there is an exponent 2 of our y. We need to retain y on the other side of the equation. So, we're going to extract square root both sides of the equation. Okay? If we're going to extract square root both sides of the equation, the exponent 2 will be cancelled out. So, you have here y is equal to the square root of x minus 2 over 3. Okay? Always remember, you need to place y on the left side. Okay, this is now the inverse equation of the given equation. Next, find an inverse of y is equal to negative 3x plus 6. Okay? Switch x and y. Y is equal to negative 3x plus 6. This becomes x is equal to negative 3y plus 6. Then next would be transpose 6 to the other side. X minus 6 is equal to negative 3y. Divide both sides by negative 3. We have x minus 6 all over negative 3 is equal to y. Then, y is equal to x over negative. I told you last time, remember that there must be no negative in the denominator. You place that on the numerator or in the middle of the fraction. So, we have here negative 1 over 3x. Then, negative 6 divided by negative 2, that's positive 2. So, this is now the inverse of the function y is equal to negative 3x plus 6. Okay. Let's continue. Inverse function. Now, given two functions f of x and g of x, if f of g of x is equal to x and g of f of x is equal to x, then f of x and g of x are inverses of each other. The symbol we have f inverse of x. Okay? This is how you're going to read. F inverse of x. So we have here, verify that f of x is equal to negative 3x plus 6 and g of x is equal to negative 1/3 x plus 2 are inverses. Meaning, find f of g of x and g of f of x. If they both equal x, then they are inverses. Then we have here f of g of x is equal to negative 3. We are going to substitute the value of our x. We have negative 1/3 x plus 2, then plus 6. So that's negative 3 times 1/3 x, you have x. Then negative 3 times 2 is negative 6. Then just copy plus 6. So negative 6 plus 6, you have, this can be cancelled out. Then the remaining is x. Next, g of f of x is equal to negative 1/3. So we're going to use this one and replace negative 3x plus 6 in our value of our x. So negative 1/3 x, that becomes times negative 3x plus 6, then copy plus 2. So negative 1/3 times 3x, we have here x. Then negative 1/3 times 6, that's negative 2. Negative 2 plus 2, that's 0. So the remaining is x. Because f of g of x is equal to x and g of f of x is x, then they are inverses. Okay, let's continue. So to find the inverse of a function, again, change the f of x to y, then switch x and y values, then solve the new equation for y. Remember, functions have to pass the vertical line test. Now find the inverse of f of x is equal to x to the power of 5. That's the question. The next question is f inverse of x a function? Okay, so we're going to look at the graph later on. So y is equal to x to the power of 5. We're going to replace x and y, interchange x and y. So this becomes x and this becomes y. So you have here x is equal to y to the power of 5. So in order to solve for y, since the exponent is 5, we need to extract fifth root each of the side of the equation. So the fifth root of y to the power of 5, this can be cancelled out. Okay? So the remaining is y. Fifth root of x. Remember, if this one, this is square root. But, and if this one, there's 3 written in the index, it's cube root. If there's 5 written in the index, we call it fifth root. So y is equal to the fifth root of x. So, if this is the graph of the inverse function, then using the vertical line test, this is a function. Okay, continue. Again, so what is again the horizontal line test? It is used to determine whether a function's inverse will be a function by seeing if the original function passes the horizontal line test. If the function passes the horizontal line test, then its inverse is a function. If the original function does not pass the horizontal line test, then its inverse is not a function. Okay, so determining if two functions are inverses, so the inverse function and thus the original function, that is, if inverse of f of x is equal to x, the function is the inverse of its inverse function if f of the inverse of x is equal to x. Example, the inverse of f of x is equal to x cubed is f of the inverse of x is equal to cube root of x. So f of the inverse of f of x is equal to the cube root of x cubed is equal to x. And f of the inverse of x is equal to cube root of x quantity cube is equal to x. Okay, so since the resulting values after doing the composition operation is x, therefore they are inverses towards each other. Okay, example, verify that the function g of x is equal to x plus 1 over 2 is the inverse of f of x is equal to 2x minus 1. So, g of f of x is equal to f of x plus 1 over 2. So, we have here is equal to 2x minus 1 because we have here x plus 1 over 2. So, every time we encounter x, we're going to replace x with 2x plus 1. So, you have here 2x plus 1, then copy plus 1, then all over 2. 2x minus 1 plus 1, this can be cancelled out. You have 2x over 2. 2 divided by 2 is 1. So you have here, the remaining value is x. How about this one? F of g of x is equal to 2. We have here 2 of our x minus 1. You have 2x minus 1, so we're going to replace g of x here. So this becomes 2 times the quantity of x plus 1 over 2 minus 1. So this can be cancelled out. So x plus 1 minus 1. X plus 1 minus 1 is, the remaining is x. Therefore, it follows that g of x is the inverse of f of x. Okay. Now, let us proceed to the assessment. Inverse relations. So, you are going to answer this in your on your activity notebook. So, find the inverse for each relation. So, we have here number 1. You are given the set of ordered pairs. 1, negative 3, negative 2, 3, 5, 1, 6, 4. And for number 2, you have the set of ordered pairs. Negative 5, 7, negative 6, negative 8, 1, negative 2, 10, 3. Now, finding inverses. Find an equation for the inverse for each of the following relations. Now, this is already expressed in equation form. It's already y, not, remember y is the same as f of x. Oh, sorry. Okay? That is the same as f of x. Okay. So, every time you encounter y, that is the same as f of x. So, number 3 is y is equal to 3x plus 2. Number 4, y is equal to negative 5x minus 7. Number 5, y is equal to 12x minus 3. Number 6, y is equal to negative 8x plus 16. Number 7, y is equal to 2/3 x minus 5. Number 8, y is equal to negative 3/4 x plus 5. Number 9, y is equal to negative 5 over 8x plus 10. Number 10, y is equal to 1/2 x plus 8. Number 11, y is equal to x squared plus 5. Number 12, y is equal to x squared minus 4. Number 13, y is equal to the quantity of x plus 3 squared. Number 14, y is equal to the quantity of x minus 6 quantity squared. For this one, you have to state if the given functions are inverses. Number 1, g of x is equal to 4 minus 3 over 2x. 3 over 2x. By the way, you have to show your solution if the composition of each other are a result to x. Then f of x is equal to 1/2 x plus 3 over 2. Number 2, g of n is equal to negative 12 minus 2n all over 3. F of n is equal to negative 5 plus 6n all over 5. Number 3, f of n is equal to negative 16 plus n all over 4. G of n is equal to 4n plus 16. Number 4, f of x is equal to negative 4 over 7x minus 16 over 7. G of x is equal to 3 over 2x minus 3 halves. Number 5, f of n is equal to negative n plus 3 quantity cube. G of n is equal to 3 plus n cube. Number 6, f of n is equal to 2 times the quantity of n minus 2 quantity cube. G of n is equal to 4 plus cube root of 4n all over 2. Number 8, g of x is equal to negative 2 over x minus 1. F of x is equal to negative 2 all over x plus 1. Okay. Then, the same as number 3 to 12, find the inverse of each function for 9 to 12 here. So, h of x is equal to cube root of x minus 3. Number 10, g of x is equal to 1 over x minus 2. Number 11, h of x is equal to 2x cubed plus 3. The number 12, g of x is equal to negative 4x plus 1. Okay? So, you have to answer all of these activities on your math activity notebook. So, I hope that you learned already on how to solve for the inverse of a given function, and you know how to verify if the two given functions are inverse with each other. Okay? And to end this video, let's have a quote. This is from www.cimathsolutions.blogspot.com, where math is an acronym which represents mistakes allows thinking to happen. So that would be all. Thank you so much for watching, and I hope you learned something in this video lesson. And don't forget to subscribe to the channel. Bye!